Let's start.
This video will be the last step before moving on with the PCB. And so in this video I would like to show you the full recap of the project. The hardware, the software, the firmware, the audio of the project and how everything works together. And if you are totally new here, the basic idea is just to have an alternative way of doing your Anki cards. Basically with only 3 buttons and your headphones. Before explaining the logic, let's have a look at the hardware first. First we have the ESP32C3 Super Mini that is super cheap and also it is perfect for Wi-Fi applications. Then, as you can see from the breadboard, we got 3 buttons that are necessary for the study session. Later we are going to see the purpose of each of the 3. Next, we got the Wimbond external memory for storing the audio files of the study session. And then, on the audio part, we got the digital to analog converter, since the ESP32C3 doesn't have an internal digital to analog converter. And it is the PCM5102A from the TI. And after the digital to analog converter, we got the TPA6132 that is basically an headphone amplifiers connected with a TRRS module for connecting our headphones. And finally, the most important part, a computer. In this video I'll call this computer also a local server, but you will see why later. And now it's finally time to have a look at the logic of the entire project. And so let's start from the beginning. The first thing you're gonna need is a computer running 2 things. The first one is the Anki software, because in this way we are enabling the REST API of Anki. If you want to enable it too, make sure to have the add-on of the Anki Connect. The second thing is a local HTTP server. With this server we are asking to Anki the cards of today's study session, and basically we're going to create the audio files based on the cards. After the PC part is done, we're going to talk about the ESP32. And since the ESP32 will be connected to the same Wi-Fi network to the PC, it can handle HTTP requests with the local server. And so in this way the ESP32 can receive the audio files of the flashcards and then it can send back the results. And this is the basic logic of the ESP32 job in this project. But let's get into the details. The ESP will receive firstly a list of all the cards due for the day. Then it will start a 4 cycle for each of the card so that it can download every audio files related to that ID. After downloading all the audio files stored into the Wimbond external flash, it will start another 4 cycle, and this will be the study session, because the first thing that will be played is the front audio. Then the user with the yellow button can reveal the back, and then after the back is revealed, the user can decide between the easy button and the again button. If you have used Anki, you know that Anki has 4 buttons. But in this project I decided to use only the first one and the last one, so the easy button and the again button. The third button is useful for replaying every audio file in the study session, so that if you have missed something you can replay every audio. After this 4 cycle all the results are stored, and then at the end of the 4th cycle the ESP32 can send back the results, as I said, to the local server, and the local server will update the Anki software, just as if you have studied all the cards from the Anki software. I'm on GitHub, this is the repository of the project, and we're going to see the script of the server and the script of the ESP32. So let's start from the server. We're going to see 2 main jobs. The first one will be creating the audio files for each of the cards, and then we're going to also see all the functions used for communicating. But the first thing is to get the Anki cards, and so we are using this function right here. Then, with this 4 cycle, we are creating the audio file for each of the cards. If you are interested on how to use the Anki API, I made a video about this project when I was working on this script right here. So check the description and you will find the video. But after all the audio files are created, we're going to talk with the ASP32. This is the function that will ask for the list of all the cards ID. And then with this one, the ASP will ask for the audio file related to the card ID. It's actually pretty cool because it's so simple. And then with this function right here, it will send back the results. Before moving on, this is the main of the script. So as you can see, it will clear the folder related to the audio files before creating the new one. Here it will get the new cards, and this is actually the function to start the local server on the port 8000. It will be a local server so that we can use the HTTP communication over the Wi-Fi network that I'm using. So with this configuration, it's not possible to use the Anki device away from your Wi-Fi network. This is the ASP32 firmware, and from the look of it, you can see that I've created the script with the ASP IDF. Initially, I started with the platform IO, but then I changed to the ASP IDF. And now let's see how the firmware works. These are all the files that I created for the project. This is the main script of the project. With this one, we can see all the logic that I explained before. So the first thing is to mount everything here. Keep in mind that all these functions are related to the external files that I made. So the first thing are these play audio files, the script is starting. Then right here we can see the HTTP boot, that is the function related to the function that we have seen on the Flask server. So with this one, we are going to receive the list of the cards ID. So right here, as you can see, we are downloading all the audio files, and this is the first cycle that I was talking about in the logic section. Basically, with this play audio, we are going to know that the downloading has finished, and right here, this is the main part of the entire project. This is the study session. It will check if the card exists. Then we're going to play the front. We have the ID, the blue button for repeating the cards, the yellow button to reveal the back. Once the back is revealed, we can choose the is with either the button 1 or the button 2. The logic is the same. With the 1 button we can choose again, with the 2 we can choose easy, and with the 3rd we can repeat the audio. With this function right here, we can decide if we knew the cards, we didn't know the cards, if we want to repeat the cards, and then we're going to store the results. And after this first cycle will be done for every card, we're going to send the results to the Flask server with this function right here. And then we know that the study session is complete with this file audio. All these file audio, as you can see, are stored into the little fs path, and this will be the internal flash. All the audio files are stored into the external flash, and the internal flash will only contains these audio files right here that will guide the study session. I prepared 5 cards for this project, and now we're going to connect the ASP to a power bands and the TPA module with my headphones.
Let's start. Blue to download or yellow to start. All files deleted. Downloading files. All files downloaded.
Die Ahnung, on. Die Ahnung, on.
Idea, suspicion.
Abstimmen, stimmt ab, stimmte ab, hat abgestimmt.
To vote.
Akzeptieren, akzeptiert, akzeptierte, hat akzeptiert.
To accept.
Allerdings, allerdings.
Admittedly, certainly.
Das Amt, her.
Office.
Der Anruf, Der Anruf,
Call. Session complete.
Thank you for watching. If you have come this far, tell me what you think in the comment section, and yes, I upgraded the camera, so tell me if I look good with this one, and we're going to see in the next one.